Hi-ho, this is Mr. Movie. Our music teacher is going to buy guitar strings for her class. At store A, the guitar string costs $6 each. Is that real? $6 for a guitar string? Okay. Well, you got store B. The guitar strings are $20 for a pack of 4. All right? Use the pen tool. I will use my pen tool here to make graphs that show the income that each store gets if the teacher needs 1 to 20 guitar strings. So I'm going to help you make the scale here for these. For the guitar strings, number of strings, that's going to be on the x-axis. Count by 2s. Okay, so 2, 4, 6, 8 all the way down the line. Am I there? Yeah. No. 2, 4, 6, 8, 14, 16, and there's 20. All right? So those are the number of guitar strings that the teacher needs to buy. And the y-axis will be the money that the store will get. And for those, you have 2 grids on your paper, right, on page 9. For the one on the left, I made my scale go by 12. $12, $24, $36, $48. Got it? So that by the time you get to the top, the highest grid line is 120. All right, so you're counting by 12s. For the grid on the right, I counted by 10s. 10, 20, 40, 30, 40, 50, 60. Okay? So for the grid on the left, each Y is 12. For the grid on the right, count by 10s. And you'll have a nice graph for both of them. So we are ready to graph the store A, and what we want to do is we want to graph, let's see, at store A, each guitar string is $6. So what's my scale here? 12, 24, 36. We're going to use dots to make the graph here because you can't buy guitar strings in increments that aren't whole numbers. So here we go. So if she bought 2 guitar strings at $6 each, how much would that cost? 12. If she bought 4 times 6 is 24. If she bought 0, how much income would they have? 0. Would this trend continue at store A? Yes. Okay, going up to as far as you can go on the paper. Now, since we counted by 2 for our x-axis, technically there are more dots here, right? She could buy 1, she could buy 3, she could buy 5. We only have the even numbers graphed, but that's okay. You good with that? So that's what your graph on the left should look like. For the graph on the right, I'm going to clear the screen and start over. So give me a second to do that. All right, my scale's magically appeared. If you're watching this from home, we have the strings going by 2s, going up to 20, number of strings that she needs. And on the y-axis, we have the scale going by 10. So if we don't need any, how much would it cost? 0. At store B, remember that we are buying 4 packs for $20 each. So if you need 1 or 2 or 3 or 4, what's the cost? 20, right? So what do you think of that? You need 1, it's $20. 2, $20. 3, $20. 4, $20. 5? 5? You have to buy another 4-pack, so your price would jump up to $40. 6, $40. $40. $40 if you need 8. If you need 9, guess what? Got to buy another 4-pack, so your price jumps up to $60. Now this could be different than any type of. If you need 9, so you're beyond there, it jumps up to 60. Keep going. Jump up to 80. Jump up to 100 if you need 17, 18, 19, or 20. So that graph looks a lot different than the graph from before. A couple questions here. We need to describe the graph from before. If you're watching at home, sorry, it's erased. It's no longer on the screen. Hopefully it's on your paper. Describe the red graph that I had up there, everybody. What was it like? Name it, give me a word. A line, I heard. Linear. What was its slope? In dollars per string. 6. It was with the slope of 6. Is this linear? The blue one? Not really. There's a different name for a function like this. What does it look like to you? Stairs. This is actually in math called a step function, all right, because it looks like steps. You're stepping up to the next step. You might see a graph like this in problems about like a parking garage. If you're there for this many hours, it's this much money. If you go past this, it jumps up to the next amount, all right? So that's describing the two graphs. They are different. This does sort of have a slope to it, right? If I were to make a line here, connecting these, well, it's a bad line, but, right? Could I? Could I make a line that connects these dots? So it is going up in a sort of a linear fashion, but it's pausing and then going up and then going up and then going up. All right, what else do we have here? Compare the graphs of store A and B. For what numbers of guitar strings is it cheaper to buy from store B? Let's think about that for a minute. What amounts would you need where you'd say, you know what, I'm going to go to store B because I'm going to save money? Think about that. Just went to a blank screen here so we can take a look at store A versus store B. What if you needed 1? How much would it cost at store A? 6. If you needed 1 at store B, 20. Ugh. 4 at store A, 24. 4 at store B, 20. Okay, so here we're happier here? No. There, if we need 1, we're happier here. If we need 2, are we happier at store A? 2 would be $12 at A, 20 at B. 3 would be $18 at A. How much at B? 20. 4 would be $24 at store A, $20 at store B. What about 5? 30 versus 40. 35 versus 40, right? Oh, sorry, what's 6 times 6? 36 versus 40, yeah. So it's going to continue to be cheaper at store A until, yes, sir. No. That's what I put. I said at every right endpoint on our little graph there on those steps, 4, 8, 12, 16, 20, it is cheaper at store B. All right? Because then you're getting more bang for your buck. You're getting a 4-pack. Make sense? Cheaper at those amounts. That concludes our model and discuss. See you next time.